And now I would like to welcome Nini Chen. He might have the longest commute of all of us. He came all the way from Taiwan. And I hope your air travels were more pleasant than some of us had to deal with Deutsche Bahn. Nini Chen is a security researcher at the IT security firm DevCore in Taiwan, and he's also a member of the CTF team Belsen. So he likes to do the more hacking part of hacking and finding vulnerabilities in things. And one of these things are compressed folders. So we will hear a story about how Windows had a bit of a pickle. Welcome, Nini.
Hi. Hi, welcome to the talk. In this talk, I'm talking about the vulnerabilities I found in Libarchive and the story behind it. And it will be a long story, so I will speed up myself. And in case you want to know, I drew the cover by myself, without any generative AI. Yeah. And yeah, I'm Nini Chen. I'm currently a security researcher at DevCore. And this is how you can contact me. If you have any question after the talk, feel free to contact me. And let's start the talk with an introduction. First, let's talk about the compressed zippy folder. It's a feature integrated into the Windows file explorer. You can browse a zip file without decompressing it, just like this. The vulnerability found in the compressed zippy folder are mostly MOTW bypassing. What is MOTW? It's a mark of a file that let Windows know the file came from the internet. An example of MOTW is when you download a file from the internet, the browser adds mark of web to the file. So the smart screen can alert you while you're trying to execute them. The MOTW is achieved by adding the alternative data stream to the target file on NTFS. We can see there is an ADS called zone.identifier added for the MOTW.zip file. The content of the ADS is straightforward, just plain text. The second line, zone ID equals 3, is the most important, which means the file came from the internet zone. But MOTW.zip is not executable, right? So Smart Screen should check the MOTW of the executable file inside the MOTW.zip. Of course, if you try to decompress the zip file using the compressed zippy folder feature, File Explorer will add a MOTW for every file extracted from the zip file with MOTW. So usually, when extracting a compressed file with MOTW, the process goes like this. File Explorer first extracted a file inside the archive. Let's call this file sum.exe. Then the File Explorer writes metadata to the zone identifier ADS for sum.exe, and that's it. And then a bypass was found, which was assigned CVE 2022-41049. It's a the scenario is if a read-only file is packed in the zip file. When File Explorer decompresses the read-only file, it will make it read-only right away. So if the File Explorer tries to add MOTW to this file, it will fail and be a MOTW bypass. The vulnerability in the compressed zippy folder are mostly MOTW bypassing, just like I just mentioned. MOTW is still prevalent in phishing campaign or malware delivery. Then, after the update in October, back in 2023, Windows 11 can browse and decompress 11 more file formats natively. Will this feature create a new MOTW bypass weakness, or will it introduce a new attack surface? The component responsible for compressed file is zipfolder.dll. Apart from the czip folder class, which implement the compressed zippy folder we just mentioned, is czip folder. There's a new class, archive folder, is for the rest of 11 new formats. So from now on, I will call the old feature, the czip folder, zip folder. And the newly supported feature, I will call it archive folder. Okay. These two classes are responsible for the logic while user interacts with the archive file. For example, show the file list when opening the archive file, or how to extract file, etc. Before doing some reversing engineering, our first step is to black box test the new feature. Okay, the first question that comes to my mind is how the user doesn't need to extract files, but can still interact with the file inside the archive file. That's because when user open the file in an archive, File Explorer will create a temp folder and extract the file into the temp folder. So the first thing I want to test is zip slip. Okay, we start with some simple example. We have a small trick here. If you create a file which is file name contains a backslash and compress it into an RAR file, then on Windows it will be considered a file in a directory. So it's very easy to test. You want to create some directory. So the first test case is ../poc.txt. Case 1, when we open the file in File Explorer, we saw nothing because the was canceled out. Yeah. And then we compress the second test case, 123 /poc.txt, and open it in the File Explorer. As you can see, because 123 was canceled out by the ../, so we can only see a poc.txt. And if we open the txt file and go into the corresponding temp folder, just I say, because when you open such file, File Explorer will decompress it to a temp folder. So maybe we saw nothing there, but maybe we just pass traversal from the temp folder. But we still see the file is inside the temp folder in this case. So there's no pass traversal or something weird currently. Okay, everything looks fine, but instead of clicking the file to trigger the extraction, we can actually right-click the file and choose Extract All. Okay, in the case 1, the system now alerts you that the path in archive you want to extract it contains an illegal path. Okay, and in the case 2, the extraction was successful, but the folder is still canceled out by ../. But hey, since we are testing like something extract all, so I think we should try an absolute path instead of the relative one. So let's try the demo 3 with an absolute path c:\poc.txt, which points to a file in C volume. Okay, so when we extract this file, the extraction was successful, but the C column was replaced to become C underline. So nothing is interesting, but we forgot something. Instead of extracting the file, what happened if we double-click the archive folder? You got a local disk C. What does that mean? You got a local disk C. That means you got some free storage now. Okay, apart from free storage, where will this local disk lead us to? Sorry. Let's double-click it. So that's a folder called POC, which is correct because we just put it there, right, in our test case. So we are still browsing the real demo3.rar, and the weird local disk didn't bring us to something weird and out place. No. So let's try to double-click the POC folder it will show the POC TXT, which is also correct because we put it there. But what happened if we open the TXT file? Yeah, look normal, right? Yeah, except the fact that I got an extra POC folder in my C volume. Yeah, so yes, there is also a POC.txt inside that folder. That means a path traversal happens while File Explorer extracts the POC.txt to the temp folder. And I think the local disk C, the local disk C is the temp folder. So now we have an arbitrary file write vulnerability, but only with user privilege. Okay, we have a lot. And as we mentioned, because it's a temp folder, so it should be removed at some point, right? That will happen in the old feature, zip folder. This will happen when the user leaves the zip folder you just browse. So the temp folder will delete them when the user leaves the zip folder. So how about the new feature? Does that also apply to our vulnerability? Will the POC.txt under C volume will be deleted? The answer is no. The answer is no because the developer forgot to flush the temp folder when you leave the new feature. They forgot to flush it. But if the victim closes another zip file, that will trigger flush. So all the temp file will be deleted immediately. Yeah. Thus, we actually have arbitrary write and arbitrary delete. But it's useless and funny because you must construct a long path like identical to your target file and ask user to click on the file hidden deep under a bunch of folder, whether for arbitrary write or arbitrary delete. So it's basically useless. And that's the CVE 2024-26185. And it's useless, but according to the rules, Microsoft have to pay me $1,000. Yeah. Yeah, not bad. And it was a good start, and I thought I could find more funny bugs like this if they always code like this. Yeah, let's investigate why the column was replaced during the extract all, by double-clicking bypassing. That might help us to discover more bypass methods. Then we found, because there is a sanitizer in zip folder.dll, the sanitizer will replace some invalid charts by underline. And there are 3 different ways to decompress file in a zip or archive folder. We only discussed the archive folder here. 3 behaviors correspond to 3 different functions. The first one is double-click. Yeah. The second one is sometimes you will see an alert window that may pop out when you double-click a file like .txt or .bat, because this kind of file often has dependencies like DLLs or other scripts. So the File Explorer will ask you if you want to extract every file in this archive folder, so maybe your program can work correctly. The last one is right-click the archive file and choose Extract All. So there are 3 different behaviors and their corresponding functions. After tracing this function, it's apparently they all call the extract archive entry to do the actual extraction. As you can see, only extract from archive by index doesn't sanitize the path. Okay, so that's the root cause of path traversal because it forgot to sanitize the path. And several months later, Microsoft patched the vulnerability. So we test to see if the patch works or not. I just opened some test case I created several months ago. And hey, one of my POC is still working. I don't know why. Let's see how they patch the vulnerability. We can see that in the patch version of zip folder.dll, they do add the sanitizer, which is replace invalid patch charts before the dangerous function. So the execution flow is now become this. It looks perfect. So what's going wrong? The test file which triggered the vulnerability is /poc/poc.txt. So let's see what's happened by following the patch version of zip folder.dll step by step. The file name will firstly pass into the sanitizer. And because there's no any invalid characters, the result will still be the same. The problem is when it comes to a function between two functions. The file explorer currently doing in this code is trying to extract files to temp folder so the user can interact with the file in archive folder, right? So it must concatenate the absolute path of the temp folder with our file name. But here's the problem. C:, and / both are roots in the Windows system. That means these two paths will be considered absolute paths. What happens when you try to concatenate two absolute paths? The answer is you only care about the second path. So the result will be C:, /poc/poc.txt again, and trigger the vulnerability. This is CV 2024 3A165, patch by patch. Now let's dig deeper. The root cause of the CV we just discussed is the absence of the of sanitizer. Can we bypass the sanitizer even if it's there? We try to construct some path without those invalid chars. For example, the dot looks very evil. Also, we try to use some prefix like device map to see if we can do something evil. But it just makes some directories. We can't actually access a remote file system. So both test cases failed. But that's because we only try to extract the regular files. What if we make it a symbolic link that points to a remote file? Okay, let's make a symbolic file point to a remote file. As you can see, File Explorer will display the file type of the poc.txt as text document, although it's actually a symbolic file. Because File Explorer determines the file type solely by the file extension, this makes it highly likely for user to be deceived. When the user extracts the whole archive file, there's no need for the user to click the symbolic file. Windows will send your NTLM hash right away. So when you extract all, and yes, we got the NTLM hash. Yeah. However, there's a big problem. The feature to extract symbolic link of File Explorer is actually implemented by create symbolic link A. And the process must be privileged to call the create symbolic link A API. That means the File Explorer needs to be privileged to use this feature. Who will open your File Explorer as admin? So the feature extract symbolic file in the Explorer is basically useless. However, the File Explorer calls the API with a special flag, which is symbolic link flag, allow unprivileged create, which looks promising, but you must enable the developer mode or the flag will not function. So to use this extract symbolic link in File Explorer feature, you must run your File Explorer in high privilege or enable the developer mode. Or you will get an error. So the feature itself is basically unusable. It doesn't even try to ask you for privilege, spawn a new process or prompt you with the UAC. So yeah, the vulnerability can only be used to attack the admin or developer. It's not a thing to Microsoft. So let's move on. We talk about some high-level interaction with File Explorer. We haven't explored decompressing much yet. Windows use Libarchive to decompress. Libarchive is an old and popular library that supports multiple archive file formats, And a lot of projects also use it to deal with decompression and compression. And after we investigate the Libarchive, we found something interesting. The fun fact one, Windows supports file formats more than they claim. Okay, as I mentioned earlier, Windows 11 supports 11 new file formats, but actually it supports more than 11 new file formats. In the zip folder.dll, we can see that it calls 3 API to initialize Libarchive, which is archive read support format all, archive read support format row, archive read support filter all. In archive read support format all, it actually enables the support of 14 formats, but there is an empty one, so 13. In the archive read support filter all, it enables the support of 13 kinds of filters. So does that mean Windows 11 actually supports 169 file formats? Wrong, more than that. You can apply up to 25 filters to a file. So that's a huge number. And fun fact two, file format confusion. If we put a zip file in an RAR file, just like this, and open it in File Explorer, we will only see the POC2 file, no other files or directories. And if you try to extract the whole file, only POC2.txt will be extracted. So how could that be possible? That's because when using Libarchive, you don't need to tell Libarchive the target file format. Libarchive will try to figure it out. Here, we can see that Libarchive will iterate all file formats and call a corresponding bit function, BID. Each bit function returns a bit value, which indicates how a file looks like a certain file format. Whichever value is highest, Libarchive will consider the file in that format. Let's take this AR file format for example. If the first 8 bytes of the file match the magic signature, the 64 is returned as the bit value. It looks promising because the 64 comes from 8 bits times 8 characters, right? Makes sense. But how about this, RAR5? Its max bit is 30, but the magic, the signature of RAR5 is apparently longer than 30 bits. I still don't know how this value was derived, but that's fine because what could go wrong, right? It's hard to build a polyglot. File if they check a file from the beginning. So, yes, except for one file format, zip, which has a special mode, seekable. It will search the whole file for zip signature. Its highest bit value is 32. So when you try to decompress a file with a low compression ratio, in this case, an RAR file that contains a zip file, the signature part of the zip file is still untouched because the compression ratio is low. Libarchive will think the whole file is something it doesn't know, but contains a seekable zip file. So the Libarchive will start passing the file at the beginning of the zip file and ignores everything else. Okay. Fun fact 3, sometimes Libarchive tries to spawn an external executable. When reviewing the source code of the Libarchive, we found that when compiling, if the system doesn't have a library for certain file formats, Libarchive will try to execute an external command to help decompress the file format. For example, as we can see here, Libarchive will execute lzop-d to decompress the file if the library is unavailable at compile stage. Then, we decompile the binary from Windows and found the Windows 4K version of Libarchive will also try to execute an external binary when decompressing some file formats, such as LZOP. And because Libarchive will try to recognize the file format automatically with the content of the file, we can make Windows to decompress an LZOP file for user by changing the file extension of a LZOP file to .rar. So when double-clicking this LZOP file, we can see that the File Explorer will try to search LZOP in path. So these are something interesting, but actually useless. And after seeing this weird behavior, we saw the component was worth a look. The attack surface seems big because we can trick Windows into decompressing almost every file formats Libarchive supports. If a vulnerability hides in one of the file formats, reaching the piece of code is always possible because we can cheat Windows to decompress it. So before actually reviewing the code of Libarchive, let's first look at two vulnerabilities Microsoft found back in January. The first one is OOB write in execute filter E8 of RAR. In the first vulnerability is simple. The function tries to ensure the length variable has to be less than 4 at line 8. But in a for loop, the length minus 5 would cause variable I to underflow to a big number. So they cause OOB write. But that's not what we are care about. The problem is, what is filter E8? The filter differs from the Libarchive filter we mentioned. This filter is something implemented inside the RAR file format. Do nothing about the filter we mentioned before. To know what is filter in RAR, we must know that there is a VM in RAR, and it's a register-based virtual machine. It's possible to write programs to improve compression. These programs are named filter. The EA filter is for Intel binary. So what is EA? That's because EA is the OP code of code instruction in Intel ISA. But what is the relationship between code instruction and improving compression? Here's an example. If we have an assembly code that calls a function, font A, twice at a different position, the machine code of the code instruction is calculated from the relative precision of the target function and the address of the next instruction. So, though the two instructions call the same function, their machine code is different. That will cause the compression ratio is very low because they have different content. So in the first instruction, hex 1b is calculated by subtracting the target function address from the next instruction's address, and the second code is calculated the same way. So because this is easy to calculate, why don't we just replace them with the address of the target function? Then their machine code would be exactly the same. So the RAR file would be smaller. Then while decompressing, the archive file should be recovered if it was preprocessed. This whole mechanism is the E8 filter. For now, let's put it aside and look at the next CVE that Microsoft found. The CVE 20696 OOB write in copy from LZSS window to UMP. It's also simple. The type of the false argument could be a negative number that can pass checks and cause an OOB write. Those two vulnerabilities looks very simple, but I did not quite understand how to construct those arguments to trigger the bugs. Because those values are not something at the file format level. There are some value calculated from the decompression procedure. So here's what I did. I start the fuzzer, add some seed, and let it run to see when it would crash. The function related to those two CVE deal with filtering. So I need to craft a seed that include an RAR file with a filter. And that way I could trigger the vulnerability. And guess what? the first crash happened way faster than I expected. It only takes 56 seconds. Yeah, but that's not only weird, but very weird. Because OSS-Fuzz has fuzzed Libarchive for several years. How did this happen? Is it because I'm super lucky? Okay, let's have a look at the report on the OSS-Fuzz website. Obviously, the code coverage is too low. If we check the code coverage from the file view, we can see that most of the file is not well fuzzed. So perhaps my seed is better. I just let the fuzzer do its work while doing the code review. Fuzzer found another 2 OOB read, okay? And one day, someone opened an issue on Libarchive's GitHub repo. It turns out that they remember to add a special flag, don't fail on CRC error while compiling. But since they didn't define it as an option in CMake, so it hasn't been taking effect for years. After the fix, the code coverage of Libarchive on OSS-Fuzz became 63. And in the file view, we can see that the coverage is significantly better than it was previously. Okay, so let's just put fuzzer aside and do some code review. And by reviewing the vulnerability the Microsoft found, we knew they were all in the RAR file format. They are all new feature, so I just did some code review, and I also find another bug. It's very easy, and it happened in the copy from LZSS window. In also the fourth argument, they don't have any boundary check, so you can, all be right. So let's go back to the coder. We said that buffer where the OOB write will happen is the filters. I almost run out of time, so let me skip some part of my slide. I also found some OOB write in the filter, and that's because it was not found by fuzzer, because you have to supply the exact data as you claim in the file format. So it's hard for fuzzer to find such bugs. But I found it, and this is not easy to construct a POC because the length of the filter is not in the file format level, but in the data. And in the beginning of the data is actually a Hoffman tree. So you must construct your payload in a Hoffman encoded code, and it's not consumed by byte by byte, but 7-bit by 7-bit. So you need a good hex editor to do this work. And let's skip this part. So when I talk about the reviewing CVE found by Microsoft, I said it's hard to construct a valid POC. So I use fuzzer to find the POC. And you must be wondering why I don't just go to GitHub and see what's going on. Maybe there is a security patch, security advisory, commits, test file. No, I did try, nothing there. 2 vulnerabilities that Microsoft found were released on January 9. And yes, Microsoft did patch them on Windows 11. However, the patch was not merged until after 3 to 4 months. Anyone who analyzes the Windows patch can attack service that use Libarchive. So we found some app on grep.app. And so let's take ClickHouse for example. In ClickHouse, you can extract zip file by such command. So, but it only support zip, tar, and 7z. But if you look at the source code, you will find the tar and 7z was implemented same open file. In the open file, you will see the similar pattern. Archive read support filter all. So actually, you can treat ClickHouse to extract every file format that Libarchive supports. So we can trigger those 2 vulnerabilities Microsoft found in least 3 to 4 months because no one knows there is a vulnerability, but it's not a 0 day. It's kind of 1 day because if you reverse the Microsoft patch, you will know that there are tons of Libarchive on the world, and there's no available patch for them because the patch was not merged yet. Okay, so let's skip this part. It's just some ClickHouse trick. And in ClickHouse, you can create a file, but it has some metadata. So if you want Libarchive to consider your file is an RAR file, you don't want this metadata. But we can select the file format at the second argument. There are some tab separated row, tab separate with names. So we can actually create a file is in fact an RAR, but with the file extension 7z to trick the ClickHouse to extract the RAR for us to trigger the vulnerability. So we use the tab separated row. The data is written by row, and each row contains value separated by tabs. So it will look like this. The problem is the tab or line feed are not allowed in each field. But there's an issue, but that's not an issue. Don't forget the filter ClickHouse enabled for us. It enabled the all filter and all formats, so we only need to find an filter which can encode our payload to avoid invalid characters. We have many possibilities to try, but a single UU filter is enough. It can be used to encode your file into printable classes. Printable chars. And now we have a polyglot file of rar.uu and the tab separated row format. Then we can use this query to let ClickHouse decompress a rar.uu file, which can invoke the vulnerability in Libarchive. We built an ASN version of ClickHouse. As you can see, ASN detects and all be right. So I report them to ClickHouse, and ClickHouse has disabled file formats it doesn't expect it to support. And they push Libarchive to fix those vulnerabilities, but the progress is very slow. No one knows what's going on. And several months later, Libarchive patched all vulnerability, but they choose to close the issue. So the problem is no one knows what's going on. And after they close the issue, I immediately submit for CVE number. But after the CVE was released, it's October, but the patch was available back to May. So in this time, any attacker can attack Libarchive and those services using it. And I'm not blaming the maintainers. It's common in open source project, especially those maintained by volunteer. Maybe they are unpaid. So I'm not sure. But unlike reporting bugs to compare to a big company, the lesson I learned is to always include a patch with your report, and don't forget to submit the CVE numbers so the community will know what's going on. And that's my talk. Sorry, we don't have much time.
Thank you, Nini. We do have a few minutes for Q&A, so like 1 or 2 questions will be possible. Are there any people lining up on the microphones? I don't see anyone. Is the internet asking questions? Signal Angel shaking his head. Yeah, that is apparently that was a very thorough presentation. All the loose threads are already tied up. That is fantastic. Who needs to do better here? Like clearly, you said that the open source maintainers are not to blame, but clearly we had a one day out in the wild for months. Who should do better?
They work on. They only work like certain week of a month, like for the first 2 weeks or the last 2 weeks. So I don't know how to contact them. I pin them on GitHub, but I don't know. But once I submit my patch, yeah, they answer me quickly.
All right. I'm still not seeing any questions, so we'll just wrap it up. Thank you, Nini.
Yeah, thank you.